Today we discuss one important theorem related to measure theory. Okay, we discuss Radon Nykodym Theorem. This one obviously one famous theorem, obviously crucial theorem for measure theory. Okay, so we also discuss this one and how why this one is crucial. We also discuss later. Okay, today we just discuss this one, that means some theorem and its proof. Okay, statement of this theorem. So we start about now. Let mu and gamma be sigma finite measures. Okay, be sigma finite measures on a measurable space. Okay, measurable space x gift a. Okay, then what happens such that gamma is absolutely continuous with respect to mu. Then what happened? Then there exists, okay, then there exists a measurable function. Then there exists a measurable function. What if this x2 close 0 plus infinity close 0 close infinity such that gamma e equal to integration e f d mu. Okay, for all e belongs to this algebra, and we marked it 1. Okay, and then the function okay, then the function if is unique, then the function if is unique, and in the sense that okay, if c x to 0 plus infinity be another measurable function such that one hold, then f equal to g mu almost everywhere on e. Okay, sorry, on x, not a problem at all. Okay, so we're now going to prove of that. Any problem? Not a problem at all. If unique and if g equal to mu almost everywhere, g is this function, and mu and gamma be mu sigma finite measure. Okay, on a measurable space x a. Okay, such that this one hold. So we erase that portion and going to further discussion of that. Okay, so proof, we write proof here and start proof now. So first we shall prove that what this the theorem and prove the theorem under finite measure. Okay, under finite measure. So we talk about that assumption that mu and sigma be finite measure. Okay, be finite measure. Then what happened? Then obviously we define descriptive f equal to those collections of f such that x to 0 plus infinity such that f be measurable. Okay, if the measurable such that integration of if d mu here a less than equal to gamma a, okay, this one where a belongs to this algebra, okay. This one is the collection of those if which is measurable, and obviously integration of if d mu less than equal to gamma a, okay. Then what happened, we suppose that, okay, suppose that what alpha equal to supremum of f belongs to f, here integration of x f d mu, okay. Then we talk about that, note that, okay, what we note that if, okay, if equal to 0 belongs to this if, thus this collection is not equal to 5, that means collection have some element, okay. Then there exists a sequence, fn in script if, okay, such that alpha equal to limit n tending to infinity integration of x fn d mu, okay. This one equal to alpha. So we now going to further discussion of that. Let A be an arbitrary measurable set, okay, measurable set. Define a1 equal to what, a1 equal to x belongs to a such that f1 x greater than f2 x, and a2 equal to x belongs to a such that f1 x less than equal to f2 x, okay. Then a1 a2 are measurable subsets, okay, of a such that a equal to a1 union a2 and a1 intersection a2 equal to 5, okay. Then what happened, obviously okay, then what happened, now we write here, note that integration of a, here maximum of f1 f2 d mu equal to integration of a1 union a2 maximum of f1 f2 d mu, okay, equal to integration of a1, here maximum of f1 f2 d mu plus integration of a2 maximum of f1 f2 d mu equal to what, equal to integration of a1 f1 d mu plus integration of a2 f2 d mu, okay, less than gamma a1 plus gamma a2 equal to gamma a, okay. Hence what happened, hence this one integration of a maximum of f1 f2, okay, d mu less than equal to gamma a for all a belongs to this algebra, okay. Then what happened? Then we erase that portion and going to further discussion of that, okay. So what happened here, okay. Hence integration of a maximum of f1 f2, okay, t mu less than equal to gamma a for all a belongs to this algebra, okay. Thus maximum of f1 f2, thus maximum of f1 f2 belongs to this script f, okay. Similarly we can show that maximum of f1 f2 dot 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 fn belongs to this f script f for all n belongs to this natural number. Now define gn equal to maximum of f1 f2 dot 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 fn, okay, where n belongs to this natural number, and for x belongs to this x and n belongs to this natural number, we have what? Gnx equal to maximum of f1x f2x dot 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 fnx, okay. This less than equal to what? Maximum of f1x f2x dot 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 fnx fn plus 1x, okay, equal to gn plus 1x. Thus what happened? Thus gn n equal to 1 to infinity va monotonically increasing sequence on f, increasing sequence on f, okay. Then what happened? Then this one is a monotonically increasing sequence f, and let g x to 0 plus infinity be a function defined by what? We erase our portion and going to discussion of that, okay. Gx equal to, okay, supremum of n belongs to this natural number fnx, where x belongs to this x, okay. Then what happened? Then gn, okay, n equal to 1 to infinity gn, what? N equal to 1 to infinity gn converges pointwise, okay, converges pointwise to the measurable function g, to the measurable function, okay, g by the monotone convergence theorem, by the monotone convergence theorem, okay, integration of e g d mu equal to limit n tending to infinity integration of c and d mu e, okay, equal less than equal to gamma e, okay, for all e belongs to this algebra. It follows that g belongs to descriptive, and by definition of alpha, we obtain integration of x g d mu less than equal to alpha, okay. It follows that g belongs to this f, and by definition of alpha we obtain this one, okay. Then what happened? Now note that fn less than equal to gn on x, okay. It follows that okay, alpha equal to limit n tending to infinity x fn d mu less than equal to limit n tending to infinity x g and d mu, okay, equal to integration of x g d mu, okay. Then what happened? Then this one, then integration of x g d mu equal to alpha, okay. Why? Because this one is less than equal to alpha by definition, and this one is greater than equal to alpha by this way, okay. Fn less than equal to g, then so this one equal to alpha. So now we erase that portion and going to further discussion of that, okay. Then what happened? Then we now show that, okay, we now show that gamma e equal to integration of e g d mu for all e belongs to this algebra, okay. Then define gamma 0, this a closer to 0 plus infinity by gamma 0 of e equal to gamma e difference integration of e g d mu, okay, for all e belongs to descriptive. And then what happened? Since integration of e g d mu less than equal to gamma e, okay, for all e belongs to this algebra, it follows that gamma 0 be a measure, okay. And in order to show this one, we mark in order to show, okay, 1, in order to show 1 means this one we marked as 1, okay. Gamma e equal to integration of gd g d mu, okay, with respect to e. Then what happened? Then here we talk about that in order to show one, we need to show that what we need to show that gamma 0 equal to 0, okay. Then what happened? Then suppose for contradiction, okay, that gamma 0 is greater than 0. Then what happened? Since mu is finite and there exists epsilon greater than 0 such that gamma 0 x greater than epsilon mu x, okay, we marked as 2. Since gamma 0 and epsilon mu, since gamma 0 and epsilon mu, okay, are measures, then we show that see that then we see that gamma 0 difference epsilon mu, okay, be a sign measure, on this script A, okay. Now we also erase that portion and going to further discussion of that. Okay, then what happened? Then hence x, okay, gamma 0 difference epsilon u be a sign measure, then hence x has Hahn decomposition, okay, has Hahn decomposition, and let Pn be a Hahn decomposition of x for sign measure, okay, for sign measure gamma 0 difference epsilon u, okay. Then what happened? Then we also talk about that we also marked is gamma 0 x greater than mu x, this one we marked as 2, okay. Then from 2, okay, we get what? Gamma 0 e intersection p greater than epsilon mu e intersection p, okay, for all e belongs to this algebra, and we marked as 3. Then again, and hence what happened? Hence epsilon mu of e intersection p less than equal to gamma 0 e intersection p equal to gamma of e intersection p difference e intersection p g d mu, okay, for all e belongs to this algebra, okay. Then what happened? Let psi p be the characteristic function, of p, okay, and by integrability of psi p and c, okay, here g plus epsilon psi p be integrable on x. Okay, now we erase that portion and going to further discussion of that. Okay, for E belongs to this algebra, we have what? Integration of E g plus epsilon psi p d mu equal to integration of E g d mu plus integration of E epsilon psi p d mu. Okay, equal to integration of E g d mu plus epsilon mu E intersection p. Okay, then this equal to what? This less than equal to integration of E g d mu plus epsilon epsilon mu psi p equal to gamma 0 E intersection p. Okay, epsilon mu E intersection p less than equal to this one, less than equal to integration E g d mu plus gamma of E. By definition, this one from 3. Okay, this one obviously by definition of gamma 0. Okay, then what happened? Hence g plus epsilon psi p belongs to this F. Okay, since epsilon mu p greater than 0 and integration x g d mu equal to alpha. Okay, then we get what? Then we get this one, x g psi epsilon mu psi p d mu. Okay, this one equal to alpha plus epsilon mu p. Okay, this one obviously greater than alpha. Okay, then what happened? Then we erase that portion and going to here a contradiction happen. Okay, here contradiction, that means we know about that. Since alpha equal to supremum of A belongs to this cryptic, here integration of x f d mu. Okay, then therefore gamma 0 equal to 0, that is gamma e equal to integration of E g d mu. Okay, for all E belongs to this algebra. Understood or not? I think all are understood that. Now we're going to the uniqueness part. Okay, uniqueness part, uniqueness of G. Here let h x to 0 plus infinity be a measurable function, okay, such that what? Such that gamma e equal to integration of E h d mu. Okay, for E belongs to this algebra. Then since gamma be finite, okay, then gamma e less than plus infinity. For E belongs to this cryptic. Then what happened? Then G and H are integral. Then G and H are integral. Okay, on X. Then what happened? Then G and H are integral on X. Then we erase our portion. Okay, erase our portion here. Integration of X G difference H d mu equal to integration of X G d mu difference X H d mu equal to here comma X difference comma X equal to 0. Okay, so this implies that G difference is equal to 0, mu almost everywhere on X, and this implies G equal to H, mu almost everywhere on X. Okay, so now we're going to discussion about next. If mu and comma be sigma finite, then what happened? Now suppose that what mu and comma are sigma finite measure. Okay, sigma finite measure. Then what happened? Then we talk about that let bn be a okay monotonically increasing sequence. Monotonically increasing sequence. Then what happened on this script A such that what? Such that mu of bn less than plus infinity and gamma of bn less than plus infinity. Okay, n belongs to this natural number. Now we apply first one. That means if this one is applied first part, that means if this one is measured, then what happened? So we apply this one and we obtain what we obtain. We obtain a measurable function. We obtain a measurable function. Okay, measurable function hn. We obtain a measurable function hn 0 plus infinity with hn x equal to 0. With hn x equal to 0 for x does not belongs to bn such that gamma e equal to integration of e hn d mu. Okay, where e belongs to this algebra A. Okay, now we erase that portion and going to further discussion of that. Okay, what happened here? We just write comma e. Okay, now let m greater than equal to n. Then what happened? Then bn, okay, subset of bm, and then what happened? Then integration of e hm d mu, okay, equal to integration of e hn d mu. Okay, for all e subset of bn subset of bm. Okay, and e belongs to this script A. Then what happened? Thus hm equal to hn mu almost everywhere on e subset of bn for all m greater than equal to n. Now define gn equal to here maximum of h1 h2 hn. Okay, then then Gn the monotonically increasing sequence, the monotonically increasing sequence, okay, increasing sequence, sorry, increasing non-negative measurable or increasing non-negative, okay, increasing non-negative measurable functions, okay, function sequence, okay. Then what happened? Sequence on x, okay. Then we may write what gx equal to limit n tending to infinity gn x, okay. For all x belongs to e equal to union of n equal to 1 to infinity e intersection bn, okay. So we write it here, comma e equal to intersection of e g d mu, okay. Now we erase that portion and going to discussion about that uniqueness of G. Uniqueness of G. Suppose that gamma is a sigma finite measure, okay. Then what happened? Then let Bn be a sequence, let Bn be a sequence, let Bn be a sequence, okay, sequence in the script A such that x equal to union of n equal to 1 to infinity bn and bi intersection bj equal to phi and mu an mu bn less than plus infinity for all n belongs to natural number, okay. Then what happened? Let mu be sigma finite, okay, and let h be another function, another function such that gamma e equal to integration of e h d mu, okay, where e belongs to this scripting. Then what happened? They note that gamma e equal to integration of e g d mu, so none about that, and here integration of g difference h d mu e equal to what? Equal to integration of e intersection x d different d mu equal to what? Equal to e intersection of union n equal to 1 to infinity bn g d mu difference e intersection union n equal to 1 to infinity bn h d mu, okay. Then what happened? Then this equal to gamma e difference gamma e equal to 0, okay. So what happened here? We erase that portion and going to further discussion of that. Hence G equal to H mu almost everywhere on E. So we get this one, this gamma e equal to integration of e g d mu. Okay, so we prove this important crucial theorem, Radon Nykodym Theorem. If you get this type of video, please subscribe my channel, and if you have any comment, suggestion, questions, please write it in comment box. And obviously you must, that means if you give like, please then raise like option or click like option. Okay, so if you get this type of video, please subscribe my channel. Okay, this one obviously important theorem, and I also discuss step by step. I think all are understand all steps. So today I stop here.